Good afternoon, everyone. So let's start the final discussion of the mock test. I think your chair preparation is going on a really smooth, and this is the last mock test. And I hope you all are doing really well in next upcoming day. Okay. So without wasting time, let's start the discussion. Which type of questions are generally come and how we can memorize more and more formula more effectively, which question we should attempt in first view, which type of questions that is we have to avoid to touch, we have to make a proper plan, okay, so that we can execute in the examination. Otherwise we can't do and we become panic. So how we can avoid such type of situation? Lot of practice, make a proper schedule, proper plan, proper strategy, which question firstly we have to try, in which portion we feel comfortable, and all these factors. Okay. So let's start our discussion. In the first question, guys, what is saying that make a proper thought process. What is the we can say ki proper plan of the J always touch each and every topics. So we should very much clear that ki we can at least formula level we can touch each and every topics. Okay. Sometimes at the when 2 or 3 days remaining for the examination, the student will become panic. So what I can do? We can't able to recall all the formulas. Such type of problems that arise, and that is obvious. But what we have to do? We just write all the formulas. Take a pen and copy and write all the formulas that you can recall. Okay, that's build a confidence and you can feel comfortable by doing this. Okay, so sometimes it will happen. So let's start the question number one, beta. In the question number one, that is the basic kinematics problem, and I hope each and every can solve this problem. Okay, here this is given that the distance covered by body in the 4 second is the twice the distance covered by the body in the second. Okay, as ns second, I can see here the question is over for me because that is the totally formula based, and I hope you everybody know what is the distance covered by particle in ns second. You can say, sir, this is nothing but u plus a by 2 in bracket 2n minus 1. This is the distance covered by particle in ns second. In first case, it is saying that in 4 seconds. So what is the distance? If we consider that suppose a particle is moving with initial velocity u and having the uniform acceleration at t equal to 0. Because this is the basic point you have to note down. So if we put this value for 4 seconds, this will equal to a by 2. That 4 to ja 8. 4 to ja 8 minus 1. So this will become 7. I hope this is clear. And in this question, it is saying that this distance is the twice distance covered by body in the second. We can say this is the twice of distance covered by the same body in second. What is the meaning of second? 2 into 2, 4. 4 minus 1, that is 3. Okay. One more information that is given, that acceleration of body that is given 3 meter per second square. If we put the acceleration of value here, what we will get, beta? That 27 by 2 equal to 2u, and this will equal to 3a, and this will equal to 9. This is not 24, this is the 2u. So what we can say here, that u equal to, beta, our u equal to 21 by 2 minus 9. If we solve this, we will easily get 3 by 2. And in the problem, initial velocity is asked. I hope everybody can solve this problem, that 1.5 meter per second. Okay, let's move for the next problem, beta. Again, such type of questions that is very easy. So we have make sure each and every topic that we can touch. Okay, not in depth level. Suppose if some topics I want to discuss, like a semiconductor and communication system, so at least you aware about the previous year questions. At least you can solve the previous 4 to 5 years question, and what I expect in this year, there are 2 to 3 questions. If we combine the semiconductor and communication skill, that is definitely asked. Please touch such type of questions. And what is the concept in particular problem, beta? If we see here, first of all, what we have to do? We have to identify the battery. This is the battery. Say this is the positive terminal. So this will get positive. This will get positive. And by default, we can say this is minus and minus. One basic thing that we already know, if diode in this manner and the positive terminal lie in this section and negative terminal lie in this section, this is known as our forward bias. This is our diode is acting in the forward biasing. And in this case, our diode is acting in the backward biasing, reverse biasing. So it is not going to be work here. So we can say that this diode pass all the current here. So this circuit can be reduced. We can say that this circuit will be reduced in this manner. This is the 2 ohm. This is 1 ohm. And effectively, we can say this voltage 6 volt. So you can easily say this branch is no more in existence because this diode is acting in the reverse bias by the polarity. So what is the current beta? We can say if current I is here, so I is nothing but net voltage upon total resistance. So what is the net voltage beta? That is the 6 volt, and resistance, that is the 3 ohm. And we will get answer here beta, that 2 ampere. I hope this is clear. That 2 ampere is the correct answer. What is the approach? We have to identify which diode is going to work here. That one is the forward biasing diode. Okay, and the reverse biasing you can eliminate in your circuit, that reverse biasing diode. The whole branch is become inactive. Okay, okay, beta. Let's move for the next question. Again, this question is the very, we can say easily question, totally formula based, that the half-life period is given, disintegration constant is asked. What is the disintegration and what is the relationship between the disintegration constant and half-life period? So as we know that beta, half-life period is written as ln2 divided over disintegration constant. So disintegration constant we can write down here ln2 upon t half. I hope this is clear. And here we know that the value it is given up ln2 divide over t half. T half that is given that 30 days. Okay. T half is given that is the 30 days. What is the ln2? Approximately, if we put the value of ln2 approximately, not exact value, that 0.7. And exact value of ln2 beta, that is 0.693. So one more thing beta, after seeing the data, you can able to, in which question you are going to take assumption. Okay, that is also depend upon your observation. So here we can replace this value with 0.7 and this will become 0.7 divided over 30. I hope this is very easy for you guys. 7 by 3 into 10 raised to power minus 2, and this will become days inverse. So I can, this is approximately, if we see the options, which option is going to be correct? If we make this value that 700 divide over 3, then we have to put minus 4 here. And by this manner, we can say this value is approximately that option C. Okay. So such type of formula based question you can solve within second beta. Okay. Let's move for the next question. Again, this is the very good problem from the, we can say, de-Broglie hypothesis. So according to de-Broglie hypothesis, as we already seen our the revision sections, which type of formula and which condition we have to apply. In particular problem, it is asked de-Broglie wavelength for the neutron. Okay, and it is given that this is the energy of neutron. Okay, so we know that there is Formula that lambda equal to h upon mv. This is the one category. What is the next one? H upon p. What is in form of the kinetic energy? 2 me. If E the kinetic energy, and what is in form of the potential? We can say 2m charge into potential difference. So here, at energy is given by unit, we can identify this. Which formula we are going to apply here, beta? That formula number 3. Okay. So we can say ki lambda that can be given. What is the h? That is nothing but 6.6 into 10 raised to power minus 34. Okay, sir. Sir, what is the mass of neutron? That is already given, that 1.67, okay, into 10 raised to power minus 27, and the energy that is given in the electron volt. Because such type of conversion we have to know. One electron volt is nothing but 1.6 into 10 raised to power minus 19. Okay, that is minus 19 joule. Because in the options, the wavelength is asked in the terms of meter. So we have to convert all the given data in the SI units by avoid the mistakes. Okay, beta. So if we put the value here, that energy value, this will become 8 into 1.6 into 10 raised to power minus 19. Okay. In order to remove the decimal 2 point right side, we have to multiply by 10 raised to power minus 2. Always see the calculation very carefully. Sometimes the calculation will reduce in very simple and easier manner. So don't be panic if such type of calculation we can't do beta. Yes, Yano? So here if we see beta, this is approximately equal. So what we can take outside beta, see here carefully, 2 and 8, that will become 16, and 16 will come outside the root, it will become 4, it will become 1.6. Okay, sir. Okay. And here, see here, that is 10 raised to power minus 19, 10 raised to power minus 21, and minus 21, and this will become beta 21 plus 27. Okay. So if we see here, what will happen here, that is the 27, and that is 21. So this will become 48 minus 48. If we take outside 10 raised to power minus 24. I hope this is clear. Okay, beta. And minus 24 and minus 34. This will become minus 10. Okay. Sir, one more thing, sir. This is something like approximately 4 plus. 4 plus. 4 plus means, sir, 4 point something. 4 point something. Okay, sir. If we divide this value is nothing but 1 point something. 1 point something into 10 raised to power minus 10 meter. See which option is the correct option. C. So what is the way how we can do the fast calculation? We have to know how we can take the good assumption. Okay, where we have to take approximate value. Okay, beta. I hope this is helpful. Such type of calculation you can know how you can do. Okay, that again this is the important problem, beta. In such type of problem, I think at least more than 1 minute you have to give such type of problem. So please be careful such type of problem. Okay, don't be egoistic. Such type of problem we can do. No, see the time, how many questions are given. After completing all the easier portion of the question, then if time allow us, then solve such type of problem. Okay, see here. First of all, it is said that two concentric coplanar circular lobes having diameter 20 centimeter and 2 meter. Okay, so here one having diameter, that if we talk about what is the radius beta R1, that is the 10 centimeter, and this can be written as 10 raised to power minus 1 meter. If we talk about the R2, that is the 2 meter, so this is nothing but 1 meter. Okay. Voltage is time dependent is given. Okay. So how we can solve? See the methodology. In the outer loop, voltage is time varying. Okay. So we have to find out actually current in a smaller loop. So first we have to think about how we can find out the current. current in outer loop, voltage in outer loop, then we have to just apply the fundamental of the magnetic flux or the concept of the EMF. Because current is in this section. How firstly we have to find out current in this section. Okay. So how we can proceed with one more thing is given that resistance per unit length is given. So how we can find out the resistance? That we can say that length into resistance per unit length. Okay. In this manner, we can easily find out the value of resistance. Okay, sir. So we can say what is the resistance of the first coil? That 2 pi R1 into, we can say this is the rho. What is the resistance of the second coil? That 2 pi R2 into rho. Okay, sir. Once we got resistance, can we find out the value of current in the outer loop? How we can find? See, in outer loop, voltage is given. And what is the voltage beta? 4 plus 2.5 T. If we divide the resistance R2 here, we will get the value of current in the outer loop. Once we get current in outer loop, can we find out the value of magnetic field at the center due to this outer loop current I2? You can say, yes, sir, B center is nothing but mu naught Ni. N is the number of turn, nothing is mentioned. Then we consider 1 Ni2 upon 2R, where R is the radius that we can say here R2 here. Once we calculate the magnetic field at center due to outer loop, then what we have to see? Sir, if the magnetic field due to outer loop is something like this, okay, sir. So we can say that can we find out the value that flux linkage with the first loop? Once we get the value of magnetic field, we can also find the value of the flux link with C beta, flux link with loop 1, that is the small loop. How beta? We know the formula, flux is nothing but B into A. But which area we have to consider? A1. We will get value of B. We just put value of B here. This value is nothing but mu2 I2 upon 2 R2 into area 1. That area 1 is nothing but pi R1 square. Okay, sir. Sir, what we have to do next? We get phi, okay, and we have to find out the current. Once we get phi, and see one more thing. Here I2 is time varying because voltage is time varying. Yes, sir. So we can say magnetic field is also time varying. Yes, sir. So flux is also time varying. Yes, sir. It means flux is time varying. It must create electric EMF. EMF. So we can say what is the EMF from the loop 1? From the loop 1. So we can say that if we want to find out, sir, we can say that, see here, that EMF is nothing but beta d phi upon dt. And what is the value of phi here beta? That mu naught I2 upon 2R2, that is 2R2 into, we can say here, pi R1 square. Pi R1 square. Here we can say I2 is time varying, so EMF we will get here. Okay, and if we see the function, that is the linear function. If we differentiate one time, then EMF will take a constant value. EMF will take a constant value. So what we have to do here, beta? Nothing we have to do, just put the value here. Mu naught, that we can write down 4 pi into 10 to the power minus 7. 2 into R2. What is the R2 is given beta? That is 1 meter. What is the value of I2? I2, that in the question it is given. No, sir. I2 we can write down V upon R2. So we can say that if put the value of I2 here, that voltage that is given 4 plus 2.5 T and divide over resistance. And what is the resistance beta? 2 pi R2 into rho. 2 pi R2. R2 is nothing but 1 meter into specific resistance, that 10 raised to power minus 4. 10 raised to power minus 4. So this is value of our current. and then we have to multiply pi into r1 square. What is the value of beta? R1 square here. R1 is beta 10 raised to power minus 1. This will become 10 raised to power minus 2. Okay. If we see in this particular problem beta, this value pi cancel out, and we can also say here beta 2 and 4 is cancel out. All the values are constant, and we simply differentiate it. Whatever we will get, that is our answer. And in this case, what is our answer? If we solve this, we can say that in particular case, our answer beta, that is nothing but 1.25 ampere. That is the simply you can calculate from here. That option D is the right one. So with the help of this question, I just want to convey which type of thought process we have to follow. Firstly, we have to see in outer loop current, because of current, from where current is come? This voltage. So firstly, voltage implies current, current implies magnetic field implies magnetic flux, this implies EMF, and EMF implies induced current. And what is the induced current beta? What is the induced current? What is the induced current beta? Induced current in the smaller loop, that E upon R1. Okay, and we already know R1, that is the 2 pi R1 into specific resistance. So in this manner, we will get appropriate answer beta. Actually, this question is a small portion of the JEE Advanced. We can say that the bunch of the JEE Advanced. Okay, we have to mentally prepare. If we have not too much time, so just avoid such type of questions. Okay, let's move for the next question. Again, this is the very predictable problem for the JEE Main. What is given here beta? In particular problem, what is given? If we see a plane mirror is made of the glass slab. Okay, and the thickness is given. A point object is placed 5 centimeter in the front of the unsilvered face. If we consider the situation here beta, what is given? In particular problem, sir, it is given that a glass slab is placed, okay, and a silvering is done on the back side. Okay, and consider that if an object is present somewhere here, and the distance of point object is the 5 centimeter from the unsilvered face. So we can say this distance is the 5 centimeter. Okay, consider if this is the surface A, D, and this is B, and this point is C. Okay. Okay, then what will happen beta? What is happen here? If we see, if we know the basic concept of the reflection and the refraction, firstly, ray from this point object is going in this manner, then the firstly refraction is occur from the AC surface. AC surface से क्या होगा बेटा? Refraction. And we know that if ray nothing is given, we can consider that the outer surface is air is present. So refractive index of air, that is 1. So air is going that from the rarer medium to denser medium, that is bend towards. We can say if moving from rarer to denser, so according to apply the Snell law, we can say that is moving in this direction. Okay, so if we extend this ray, this is the image formed by the first refraction. What will next beta? What will next? What is happening? If the second is the DEF surface, and this second surface, that we can say DF surface, that is because this is the silvered portion, reflection is occur. Again ray is passing to this AC section, then again what will happen beta? Again from AC section refraction is occur. So firstly we have to consider what is the phenomena that is going to be happen here. Okay, and we know that what is the distance by formula. So if we consider the first case, what is the formula beta? If we say this is the BI1, that is nothing but refractive index into the thickness of the glass slab. And what is the thickness that is given beta? What is the object distance that initially given? If we see the diagram, that 5 centimeters, sir. What is the mu is given? That 1 mu is 1.5. So this is nothing but 1.5 into, we can say 1.5 into 5. So this will become 7.5 centimeter. This is the distance from the unsilvered portion, that is the image formed by the first refraction. What will happen? What will happen? We can say in the second portion, if we draw another diagram, this is I1, this is I1, and what is the total distance from the silvered surface? So this is beta. We can say this is it. This distance is that is given in the problem 2.5 centimeter thick, and this is 7.5. So what is the total distance, beta? The total distance that we can say it is 7.5 plus 2.5, and in this way this distance is the 10 centimeter. What is the fundamental of the plane mirror? If an object lie at a distance x, then the image formed by backward in the plane mirror at same distance. So we can say in this direction the image is formed 10 centimeter. Say this is the I2. What is the next process? Again refraction is occur from the AC surface. Then what is the next happen, beta? Next going to be happen. We can say this distance is 10 centimeter from the silvered surface. So what is the, say this distance is I2. So what is the distance from this surface? That this distance will become 12.5 centimeter. I hope this is clear for everyone. This is the 12.5. Again we can say this 12.5 again written, beta. The final image is formed at position say I3, that BI3 into refraction occur with the help of this plane glass, that refractive index of this plane glass. And what is the refractive index? Sorry, what is the refractive index of this plane glass? We can easily say, sir, the refractive index that is the 1.5 here. So what is happen here, beta? That 12.5 divided over 1.5, that is our BI3. And this value, if we solve easily, we can say 8.33 centimeter. I hope this is clear. Firstly, refraction from the plane slab, then reflection from the silvered portion, again refraction from the plane slab. So in this way, we will get the answer that 8.33 centimeter from unsilvered portion. Listen, the distance is measured from this unsilvered portion. Let's move for the next problem. This question, again, that is the application of the magnetic force here. 3 wires are given and the ammeter show the reading 30 ampere. One information that is the very useful for particular problem. Each resistor having equal resistance. So by symmetry, if this is the total 30 ampere current, so this will equally divided. So we can say in this 10 ampere, 10 ampere, 10 ampere. What we have to find out? Force per unit length on the wire AB and CD. Okay. So here we have to find out force per unit length on the wire AB, and similar manner we have to find out the force on the CD. So मुझे एक बात बताओ बेटा, वायर 1 के सराउंडिंग में कितने वायर हैं? देयर आर 2 वायर्स. बोथ द वायर आर गोइंग टू अप्लाई फोर्स. ओके, सो व्हाट इज द फंडामेंटल, सर? If we want to find out force on wire AB due to wire CD, what is the formula, beta? Mu naught I1 I2 upon 2 pi distance between parallel wires. Here it is given the separation with the 1 centimeter. If we put 10 raised to power minus 2 meter. Okay. What is the direction, beta? Current is flowing in this direction. So due to this current, magnetic field in outward to plane of paper. Okay. Then what is the direction of force? That I L cross V, that is acting in downward direction. So force is acting due to wire CD in downward direction, and say that this is downward direction minus J cap. Okay. Just solve the value. Mu naught I1 and I2, that is equal 10 into 10. Okay. 2 pi into 10 raised to power minus 2. So here we can say mu naught upon 2 pi, and this value will become 10 raised to power 4. Direction is the minus J cap. I hope direction is clear to everyone. Okay. Just apply the fundamental. F equal to I L cross B. Extend your right hand finger in the direction of the length vector and curl your finger in the direction of the magnetic field vector. What is the force on wire AB due to wire EF? Sir, in similar manner, we can say कि I1, I2, this factor will remain same. Direction of current is same. So we can say that they will attract to each other. One again, the shortcut we can apply here. If wire are placed at particular distance, having the current in same direction, they will attract to each other. Okay. So we can also say that this wire is also attract to this wire, and this value 2 pi. What is the distance from here? That is, this is the 1 centimeter, 2 centimeter. That 2 into 10 raised to power minus 4. So this will equal to mu naught upon 4 pi 10 raised to power 4 minus j cap. What about the net force beta? What about the net force? F net on wire AB, that AB due to CD and AB due to EF. If we sum up these two values, what we will get? We can say this will nothing but beta mu naught upon 4 pi. And what will happen beta? If we take a LCM here, so what we will get beta? Mu naught upon 4 pi 10 raised to power 4 into 3. What is the mu naught upon 4 pi? That is nothing but this can be written as beta 10 raised to power minus 7 into 10 raised to power 4 into 3. So what with the value beta we will get here? That 3 into 10 raised to power minus 3 Newton per meter. This is the net force on the wire AB. Okay. In the same manner, if we talk about what is the force on wire CD, so this wire having the equal distance and attract in this direction. Okay. The wire AB also want to attract wire CD. Both the wires from wire CD having equal distance, having equal current, so we can say magnitude of force is equal on wire CD, but opposite in direction. So what about the net force on wire CD? Net force on wire CD beta, so that is nothing but F1 minus F2, and by default magnitude F1 and F2 are equal, that will equal to 0. So what is the answer beta? That 3 into 10 raised to power minus 3 into 0. Option B is the right one. That is the most acceptable problem for this JEE main beta. So mentally prepare for such type of questions. Okay, in any given format they can ask. Okay, let's move for the next question. Again, this question we can say that that is the double block problem that is asked, and it is saying that this surface is smooth. Okay, and the 40 kg, 10 kg, what will happening here, beta? First of all, a force 100 Newton is applied on the 10 kg block, and it is saying that the resulting acceleration of the slab beam. Okay, the coefficient of static friction and kinetic friction is given. So in which block force is applied? You can say it's a 10 kg. So first of all, beta, first of all, can you tell me what is the limit of maximum static friction on the 10 kg block? You can say, sir. Why not, sir? Fs maximum, that is nothing but mu s into n. Sir, we want to draw the FBD of 10 kg. Draw करो ना बेटा. 100 आएगा नीचे, normal आएगा ऊपर. Okay, sir. So what is the this value, beta? This value is the approximately we can say 100 into mu s. What is the mu s, beta? That is given 0.6 here. Okay. So what is this value, beta? This value is nothing but beta. Here we can, for the calculation purpose, we can say this is G is approximately taken 10. And you can use this value here. So approximately what we will get here, beta, this is nothing but 60 Newton. If we put 9.8, that is less than 60 Newton. Approximately slightly less than 60 Newton. So this gives an idea. Here force is applied of the 100 Newton, and the friction force that acting on the 10 kg block, that is only 60 Newton. It means block move. Block move, block A move. If block A move, so we can say kinetic friction acting on that block. Okay. So if kinetic friction is acting on that block, so can you tell me what is the direction, beta? If we applied force in this direction, So on the block A, we can say kinetic friction that is acting in this direction, and on the block B, the kinetic friction, the same kinetic friction by Newton action reaction that is acting in this way. Okay, beta, can you tell me what is this friction force? That single horizontal force that is acting on this block. You can, why not, sir? That Fk equal to mu k into n. So what is the mu k beta? That is the 0.4. What is the n beta? That 10 into 9.8. And this is the value of Fk. In this particular problem, it is asked about what is the acceleration of the block B. So this is the same friction force acting from the block B. So this is the single force, and a single force is always written that mass into acceleration form. That is the cause. Force is the cause, and acceleration is the effect. So we can say this is equal to 40 into A. So if we solve this value, what we will get here, beta? That A equal to 0.98 meter per second square. I hope this is helpful. How we can decide the block will going to move or not. If once we sure that block is going to move, then kinetic friction is act by Newton action reaction. The both same friction act on the lower block, and this is the single force because lower portion is the smooth, and that cause that effect acceleration, and this acceleration is 0.98. Again, that is the one short type of problem. You just see the question and you will just comment the question if you know the all the conditions of the lens and mirror. What is given? The lens is put on 20 centimeter, where the focal length is given 10 centimeter. So by observation, you can say, sir, this object is placed 2 times of focal length. Whenever object is placed 2 times of focal length, the image is also formed by that lens at the 2 times of focal length. This is the clue concept. This is the clue for such type of problem, beta. As we also know, in mirror, if the object is placed at the center, the image is also formed at that point. So here we can say by visualization, this distance is nothing but 2f. So image is also formed at 2f, that is 20 centimeter. And if you want to solve, you can solve by applying lens formula. If we apply lens formula, beta, you can get the value 1 by v minus 1 by u equal to 1 by f. Put the value here. Put the value that u value is nothing but minus 20 and f is the 10. You can get the value of v 20 centimeter. One more thing. If this 20 centimeter, if we place this mirror at 20 centimeter, then what will happen? The image formed by this convex mirror, something like this. Okay. And it is saying that if the final image coincide with object, when final image coincide with object, beta, when final image, when the path of light is reversible. And in this case, if we put this mirror at x equal to 20 centimeter, then the same ray revert back its path and form the final image at y, because this is incident on the pole. This is incident on the pole. This is the clue for particular problem, beta, to see the data, which type of data is given. And by seeing the data, we can say that if the ray is incident on the pole, we just reflect back all the light symmetrically. Okay. So this light is go back symmetrically. So we can say that the another side, by the nature of the convex mirror, the same image is formed at the 2f distance. So what is the distance between lens and mirror? That is the 20 centimeter. I hope this is clear, beta. What is the concept? Firstly, see this data, and this data you can, without solving, you can say image is formed and this distance. When the image is formed, exactly the position of object, when the image is formed by the lens that form at the pole of the convex mirror. Okay. So let's move for the next question, beta. The next question we can say, Again, there is in the one liner question. So firstly, we have to identify such type of question. Whenever uniform fluid is given, it means from the closed surface, the total net flux beta, this will equal to 0 for a uniform field. See the important word, uniform electric field. I hope this is clear. So what is the answer beta in this problem? That is the 0 is the correct answer. Again, this is the mix-up problem, and that is the good category problem. We can say that. Suppose that if there is a fully block system is given, that is the 2m. Just consider this is the 2m and this is the m. What will happen, beta? Unbalanced force is created, and we can say this is moving in downward direction and this m is moving in upward direction. Their string will get stretched and a tension is come, that is the T, If the pulley is massless and string is massless, we can assume the tension same, correct? But what will happen here? To balance the net force, we submerge one portion of the block is in a liquid. So what will happen, beta? We know that here 2 mg is more than tension. If we submerge in a liquid, a buoyancy force also acting in downward direction. So that's why that T and 2 mg will get balanced by the help of the buoyant force. Okay. First of all, we have to understand the thought process of the question. Okay. So, sir, if this system will get balanced, then what we will say here? We can say if we draw the FBD of mkg, of block, that simply we can say that is the mg and tension. Okay. What is the FBD of the 2 kg of block? See here, that FBD of 2 kg of block. Okay, sir. If you draw FBD of 2 kg, see here, beta, we can say, sir, that is the gravitational force 2 mg, another is the tension force T, and another is the buoyant force. At equilibrium, we can say T equal to mg, and here we can say T plus buoyant force, that is equal to 2 mg. We will put T equal to mg here. So we can say this mg plus buoyant force, this will equal to 2 mg. So what is the value of buoyant force here? That is 2 mg minus mg, that is the mg. Okay. How we can write down the buoyant force? Weight of fluid displaced. So this is nothing but weight of fluid displaced. How we can write down the weight of fluid displaced? Weight means, sir, listen. Weight means that density of fluid, okay, that is given 1 gram per centimeter cube, put the value. That density of fluid into volume of solid inside the liquid. So what is the volume of solid inside the liquid? That is given in the problem. Again given in the problem, beta, 2/3 of its volume. We can say that 2/3 of the volume of the solid body. Listen. Okay. That into G. Okay. That rho Vg equal to M into G. Sir, what is the volume? Can we write down in any other term? Because the density of water is given, and in this question density of material is asked. So can we convert volume in the form of the density of material? Why not? With the help of mass. Mass of body divided over density of body. Okay, sir. Into G equal to mg. See, beta, mg cancel out, and here what we can say that the density of body is nothing but, what is the density of body? We will get that we can say here, if we solve this value, the density of body will equal to density of fluid into 2/3. Okay, beta. One more thing, it is given that the mass that submerged is not m, that is the 2m. That is the 2m. So here we have to put 2 also here. So that's why this will become 2, and this value will equal to 4/3 density of fluid. What is the density of fluid? Sir, 1 gram per centimeter cube. So what is our answer? 4/3 into 1. So which option is correct? Option A is the correct. I hope you get a clarity how the question is formed. That first thought process, this is the unbalanced force. acceleration is come. So counterbalance this acceleration, so that this acceleration will become zero. We have to submerge one portion inside the liquid so that the buoyancy force come into picture, so that the system will remain in the equilibrium. Okay, beta. Let's move for the next question. Again, that is the very easy problem, beta. This is given the 70 joule of heat is required to raise the temperature of the ideal diatomic gas. Okay, sir. Ideal है, अच्छी बात. Diatomic. What is the meaning of diatomic gas, beta? Diatomic means sir degree of freedom तो fix है 5. CV मन ही मन में कैलकुलेट हो गया है सर 5/2R. CP 7/2R. Okay. What is the CV upon CP? Sir, we can get the value. There is no need. Okay, depending upon the situation. The first heat supplied at the constant pressure. What is the formula of the heat supply at constant pressure? If mole of the heat is N, Cp delta T. Okay, sir. Second case, heat is supplied at constant volume. What is the formula? Ncv delta T. Okay, sir. Sir, this heat is given 70 joule. Okay, sir. This heat unknown. Okay, sir. If we divide both the equation, okay, sir. So this will cancel out. What we will get? That Q delta V divide over 70. This will equal to CV upon CP. CV, sir, 5R/2. 7R/2. And what we will get? That heat at constant volume is nothing but 70 into 5/7. And I hope in the thermodynamic section, KTG section, you can say that you can expect that is directly formula based question. Again, this is the good problem from the binary star system. In the binary star system, we can say that the mass is considerable. So we can say that the role of the center of mass come into picture. It is saying that one, suppose this is the mass M and another is having 2m mass. So we know the fundamental of the center of mass. The center of mass lie nearer to heavier mass. So somewhere center of mass is lie. And we know that the distance that join the center of mass inverse ratio of their mass. If we consider that beta, what the distance between total distance, if we consider L, okay. So then what is this distance? We can easily find out. Okay, we can easily say this distance is nothing but that is, we can say here that 2/3 into L, and this distance is L/3. And one fundamental concept of the binary star system beta, that omega of both the star about the center of mass will remain same. Suppose about the center of mass, this will perform circular motion, and this also performs circular motion about the center of mass. Their omega same. Okay, sir. So what is the angular momentum beta? We know that sir, angular momentum, if you want to write down, how we can write down the angular momentum? That L1, if you want to write down this mass, that M, and moment of inertia, if you want to write down that M R square, that the distance from there, that 2L/3 whole square into omega. What is the momentum of the 2m mass beta? M L/3 whole square omega. If we see both the equation, what we will comment here beta? What we will comment here, what is going to be happen here? Okay. So by seeing the angular momentum, we can say, sir, what is going to happen here? That mass 2m, what is the relationship of their angular momentum, and on the basis of relationship with their angular momentum, we can say option is the appropriately correct. Okay. So we just, whenever the planetary motion come, we just apply two concepts. One is the total mechanical energy conservation, and another is the angular momentum conservation. Okay. The next is the question that is asked from the rocket system. If a tennis rocket system we consider here, and this portion is considered that is the circular. Okay, so it is saying that the table tennis at rectangular handle and the mass is m. So center of mass is lie at this portion, that is the m. Okay, and we can say this length is also given, that is the L. So this will become L by 2. Okay, circular plate having the center somewhere this point. Say this is the C1, this is the C2, and this is saying that the radius is R. This distance is R, this distance is also R. Okay. We have to find out moment of inertia of bed about an axis perpendicular to plane and passing through center of mass. So center of mass of the, say this is the first portion, this is the second portion. Center of mass of first portion lie at C1 and of the second portion lie at C2. And we can say that depending upon the mass, their center of mass is lies somewhere between C1 and C2. But it is given that the disk having same mass of the handle. If the mass is same, so by symmetry we can say center of mass that is lie at the between somewhere. Okay, and we can also find out where is the center of mass by the fundamental of the moment of mass. Say this distance is x. We can say if we apply the fundamental of moment of mass, either another method, you can choose origin here and write down the coordinate. You can locate the center of mass. But now I am going to apply the mass moment, that m into x. And here we can say this mass is m. What is the distance from this? So we can easily say this distance is r, this distance is l, this is nothing but beta, this distance is l minus, we can say that is the l minus x. So what is this distance will going to be happen? That m l by 2 plus r minus x. I hope this is clear. This distance is l by 2. Okay, and we have to find out the distance of C1 to C. So that is nothing but beta. We can write down here that this distance is equal to L by 2 plus R minus X. Here we find the value of X, and if we solve this value, this will equal to L plus 2R by 4. And the same value we will get here, that we can say this value is nothing but that C2C is equal to CC1. Okay, and L plus 2R by 4. Once we will get this value, we can easily find out the moment of inertia about this axis. Okay, for rod we can apply the concept of the parallel axis theorem. So firstly we can write down that ml square by 12 about the center of mass. Then we have to shift by a distance that is given here, that ml plus 2r square divided over 16. Then if you want to find out what is the center of mass about their center disk, that mr square by 2. Then again apply the concept of the parallel axis theorem. So this will become m, and this distance is also equal to C2C, that L plus 2R square divided over 16. If we solve this value, what we will get here, beta, that is nothing but ml square 12 plus mr square by 2, and this will become 2 times. So this value will equal to m upon 8 L plus 2R square. So I hope this is clear to everyone. Option D is the appropriately correct option. Again, this is the question come from the mechanical property of solid, and what is given here ki a massive object suspended from the center of mass of uniform bar. Say this is a uniform bar and a massive object is suspended from here, and we know a support required. For the support there is 2 strings are used. Okay, and what is saying that what must be ratio of diameter when object is removed. Suppose if this object is removed, so we can say that this string get tensed by because of this bar. Okay, and it is saying that the uniform horizontal bar, What is the meaning of uniform horizontal wall? The deflection in the both the string will remain same, and both the string having the length is given same. Consider the Young's modulus of string 1 is y1, second is the y2. The cross-sectional area is A1 and A2. So if the deflection will remain same, so that wall will remain horizontal, that delta L1 equal to delta L2. So what is delta L beta? By fundamental, we know that the force FL upon AY. And here, by symmetry situation, bar is uniform, the force on both the wire will remain same. So we can say here ki FL A1 Y1 equal to FL A2 Y2. Here we consider ki F and L are same. L is already given in the problem, but F is by symmetry. FL cancel out. A1 nothing but the pi by 4 D1 square. We always write down the area in such manner that Y1 A2 pi by 4 D2 square, that is Y2. So here this will cancel out, and we have to find out what is the ratio of diameter, that D1 upon D2 we can write down here Y2 upon Y1. So we can say option D is the correct. Again, this is the question that come from mixed concept of the kinematics and the viscosity. And what is given that beta ki suppose a ball is drop from some height and the ball will cover a distance h. Then ball is moving in some liquid. Okay, viscosity of liquid is given. Okay, very good. If ball just enter into liquid, then there are how many forces acting? One is the mg, another is the viscous, and another is the buoyant force. Okay. It is saying in the problem, the ball is moving with a constant velocity. Ball entering water, velocity of ball does not change. What is meaning of this? The net force on ball is 0. It means ball is moving with its terminal velocity. Ball is moving with its terminal velocity. What is the terminal velocity beta? We have to know what is the terminal velocity, that 2 by 9 r square g. Density of body if you consider sigma, density of liquid if you consider rho, divide over viscosity eta. This is the terminal velocity. If we remember this formula, we can solve problem by within second. This velocity is equal to the velocity when ball in reach at this point after traveling a distance, and this is nothing but under root 2gh. So this is equal to under root 2gh. Just solve the value and get the value of h. That is the very easy calculation. We can say 2 by 9 r, that is given here 3 into 10 raised to power minus 4 square, that 9 into 10 raised to power minus 8. G, that is nothing but 9.8. Okay, sir. Sigma minus rho, that is given, that the density of material, that is nothing but 10,000 minus 1,000. This will become 9,000. Okay, what is the viscosity that given beta? 9.8 into 10 raised to power minus 6. This will equal to under root 2 GH. See the data. This will cancel out. This is cancel out. And we can say what is value we will get here. That if we solve here, that easily we can say under root 2 GH. That easily here we can write down that 1000 and 10 raised to power minus 6. This will cancel out. So this will equal to beta nothing but here we can say easily we can solve this value, that 2 into 9 into 10, and this value equal to under root 2gh. Okay, squaring both the side, and we will get the correct answer. What is the value of h? And I hope you can solve this. You can solve this value, and this is equal to 1.65 into 10 raised to power 3 meter. Okay, thus simply solve from here, and you will get correct answer. Again, the question, that is same type of question is asked in the test also. So I hope you are comfortable for solving such type of questions. When the question is asked from the young double slit experiment, just we have to remember the diagram. This is the distance between slit to screen, okay, and that is distance, that is y, where the fringe is formed. Okay, this is our slit distance. Here it is saying that the maximum intensity is I naught. Okay, sir. If maximum intensity is I naught, D is given, that is the 5 lambda. Maximum I max, that is I naught. Firstly, we have to know the formula. What is the general formula of I beta? That general formula of I, that maximum intensity into cos square phi by 2. Phi is the phase difference. So first of all, we have to find out the phi. What is the phi? That phi can be written as 2 pi upon lambda into delta x. What is the delta x beta? Delta x always written beta. Listen here, listen carefully. D sin theta. If theta is very small, then we can say, sir, in this case, this will equal to theta and theta equal to tan theta. Tan theta is y upon d. Okay, sir. So 2 pi upon lambda small d, y that is given. We have to find out in front of one of slit. In front of one of slit, it means its distance will become d by 2. Y equal to d by 2. This will equal to d by 2. What is the value of capital D? In the terms of small d, that is the 10d. Okay. So what is the value of small d? Small d again given beta 5 into lambda. Put the value beta, that lambda into 20. So if we solve this, we will get pi by 2. Put this value here. So pi by 2 divide by 2, pi by 4, pi by 4 cos pi by 4, 1 by root 2, 1 by root 2 square, 1 by 2. So I, that is nothing but I naught by 2, that option A. Okay. So that is the expected problem. Again, this is the easy problem that is asked. What is given here, beta? Ki suppose rain is actual velocity of rain in this direction, but for the man, rain is coming in this direction. So we can say ki man is moving in this direction. Okay. What is the fundamental here, beta, that we are going to use? That velocity of rain with respect to ground, velocity of rain with respect to man plus velocity of man. Okay, this is the fundamental. If the velocity of rain with respect to man, this is the velocity of man, this is the velocity of rain. How? By using simple triangle law of vector addition. Okay, it is saying that it makes 30-degree angle with vertical, and this velocity is given 6. So if we apply simply tan 30 here, so tan 30, how we can write down? That 6 upon velocity of rain. That is the magnitude, that is the net velocity. Okay. So if we solve the velocity of rain, that this will equal to, we can say that is 6 upon tan 30, that cot 30 nothing but root 3. And this velocity is given in the a under root b form. So just compare, if a is nothing but 6, b is nothing but 3, then what is the value a plus b beta? That is the 9. In this question, we will get 9 as a correct answer. Again, this is the very easy problem. You can note down what is the answer of this problem beta, because that is the again very easy problem. Just apply the simple concept 1, 2, 5 angstrom. Okay. So I think we just apply the formula 1 upon lambda r z square 1 upon n1 square minus 1 upon n2 square. For the Balmer series, we know that n1 equal to 2, n2 equal to 3. For the Lyman series, n1 equal to n1 and n2 equal to 2. Okay. And the next problem, that again, that is the conceptual problem. You can say that if some longitudinal wave, that is the, suppose a ship is moving at some depth. If we consider suppose a ship is moving here, okay, and say this depth is d, some signal is transferred by the transducer are attached to the ship so that it can send the signal by using ultrasonic sound. So we can say that firstly, what will happen here? If we have to listen the sound, then what firstly we have to know that what is the velocity of sound that is given in the form of the Young's modulus divided over the density. Once we calculate the density, then what is the depth? So we can say that if longitudinal wave sent by ship to the bottom of the sea returns after one lifts up under root 20 seconds. If means signal is going in this way, then this will come in this way. What is the total distance? That 2d. Total distance is nothing but velocity into time. Okay, sir. What is the velocity beta? Under root y upon density. What is the time? Under root 20 seconds. In this way, we can calculate the value of depth d here. And if we solve this value, you exactly get the value beta, that is 1000 of meter. Okay, just solve the question. We just club the two concept. Okay. In the next, again, that is the very easy problem. We can say that here we have to calculate the current. So firstly, magnetic field is given. So we have to calculate the flux. Then we have to calculate the EMF. Then we have to calculate the I. And what is the order? That is the BA cos theta. What is the flux? BA cos theta. Theta is written as omega t. So this will equal to BA cos omega t. In this manner, we will get flux. What is the EMF? D phi upon dt. So in this manner, we can calculate the value that B omega cos omega differentiation of cos omega sin omega t. What is the current? Divide over resistance, that is given 10 ohm. Okay. What is the amplitude? That is the magnitude. We can say B omega divide over 10. This is the amplitude of the current. Okay. And if we put the value B, that is given here, 0.1, area 0.1, omega 1, divide over 1. And answer is asked in the milliampere. We can say 1 milliampere is the correct answer. 1 milliampere is the correct answer. Okay, beta. So remaining 2 to 3 problem you have to solve by own way. Okay. If any doubt, you can ask me and I will tell you what is the correct answer, beta. So I hope this is a crucial time for you guys. So make your confidence and try more and more problem, revise the formula. Thank you so much. Okay, beta.